limestone. They call it the sycamore limestone. So within this package, you know, the Mississippian limestone, the sycamore, and the Hunton will have, again, 350 feet thick here. Now on well logs, you know, when you're taking a look at, you know, trying to evaluate them, you can determine the siliceousness if you have the PEF, the photoelectric log. And, you know, if you have a value generally less than 3, you're in pretty good shape. Now when you have values of around 2, 2.5, that's when you get into the facies that has the actual silica beds, the cherty beds, and in which case really what you're doing is you're looking at, you know, the silica rather than, you know, the shale. So the PEF is a good log that characterizes the siliceousness of it. The shale by itself is about 3.1, 3.2, somewhere in there. But anything lower than that, it indicates that you have high silica content. So this is a shale that it doesn't have a lot of carbonates, unlike the Eagleford, which has a lot of, you know, carbonates in the matrix. And so the log characteristics are going to be different. So this is really a shale that has maybe 4 components. You got the silica, you got the clay content, you got the total organic, the carbon content, which is anywhere from 5 to 10%, and then you have the actual gas fill porosity. So those 4 should more or less add up to about 100%. Now, the resistivity on the Woodford and most of these, all of these unconventional shale clays is a real critical point. Now, in my opinion, you know, the resistivity has to be about 80 ohm meters or greater. Now, you have to remember that most shales have low resistivity. Could be 4, 5, 6, generally less than 10 ohm meters. But you start to add hydrocarbons, you know, within the pore spaces of the shale, it impedes the electrical conductivity of it. So the more hydrocarbons you have in the matrix, in the pores, it impedes the electrical current, and the resistivity goes up proportionally. And it can be 100, 200 ohm meters or more. So resistivity is a log characteristic. You know, the high gamma ray is another, and that's real easy. You know, the total counts, the total gamma ray generally should be greater than 150 API units. And again, the high gamma ray is to some degree not proportional but related, you know, to, you know, the amount of organics that's in the shale. And the reason being is that uranium in particular is soluble in oxidized water, marine water. It precipitates in reducing environments. So in reducing environments are formed when algae and stuff like that, you know, in these Devonian shales, they lived and died and they scavenged the oxygen and they created these environments that have very, very low oxygen. And that is where the uranium precipitates out. So the death and decay of organic matter, algae and things like that, causes a reducing environment which causes the uranium to precipitate out. So you see this on the gamma ray law. Now the other log characteristic is the density neutron log. And the density is really, really important. It could be bulk density.